So this is the slide I prepared for the session. Let me know if you have difficulty sharing this so I can speak up. And if you want to access the slides, you can share this. Okay. Good day once again. Okay. So the title of this session is called Streamlit Model Deployment. The learning objective would be learning about building a machine learning model, deploying models using Streamlit, and then getting the results and predictions from the deployed models. The agenda will be about what is a model deployment, and then building a machine learning model. The data has been identified, and then we'll be deploying the model using Streamlit.
Mr. Abu Bakr? Mr.?
Yes?
Your voice is like somehow like low. Can you raise your voice a little bit?
Okay.
Thanks.
What about now? Is it better now?
Yes, I think so. Yeah, thanks.
Okay, no problem. All right, and we'll be learning about deploying the models using Streamlit sharing, and then we'll be rounding it off with containerizing the app using Docker. I'll dive right in. So from what I have, model deployment is simply the method by which we integrate a machine learning model into an existing production environment to make practical business decisions. This simply means that we put in a built model into production so that we can make it available to other systems within the organizations, or we can you can use it as serving as a purpose of getting predictions from the deployed model. The end goal of this project would be to see a deployed model that is available online, and then it's easily accessible to the users of the deployed models. We will be using a data set that is used for building the loan prediction model that would say whether a particular loan will be approved or will be rejected. So it's a classification model that we're going to be building. I'm going to run through the slides so I can go into the practical sessions. We are going to be taking these following steps. We'll be creating a Github repository that will store our data, the model that has been built, the code to expose the model to the consumer so that they can use it. And the major files that is needed for a Github repository for us to deploy using Streamlit sharing will be a script which you can name anything. I'm calling mine app.py, and then a requirements.txt file. And then we will run the app using Streamlit run, and then we will grant access to Streamlit. We'll grant access to Streamlit so that Streamlit will be able to be installed on our GitHub, and then it will have access to our repository, and then allow us to deploy the model. Basically, this is the step we're going to be seeing when we deploy the models. And then we click on deploy here to see the models, and then you can see the predicted models here. That's just a small slides. There's going to be room for questions and answers. For now, I'm going to code. All right. So I provided the link to get the code as well. You can easily access the code here. You can easily access the code here. And then once you have that, you come back here and then we would start the building process. So we have two script files that we would use to build the model. We have the build model.py, and then we have the app.py file. We need to install some of these libraries that we're going to be using. Specifically, we're going to be using pandas for exploratory, for data transformation. we are going to be building a classifier with the random forest classifier. Then we are going to be evaluating the model using the accuracy score, and then the seaborn for plotting, and then the pickle to save the model. So the so I've already written the script to save us from debugging errors and the likes. So we have the function to load the data, which only receives the file path, and then we have the function which helps us to transform the data by converting categorical columns to integer variables, because that's what our models would use. And then we are dropping out the missing values, and then we are selecting all of our features, and then we are selecting the target as the x and the y variable. Then we're just printing out the shape, and then we are returning the x and the y variable. We have the build model function, which helps us to build the model. This takes in the features and then the text, and then the target, and then it returns a random forest classifier. There's a little bit of parameter set here, which is the max set is set to be 4, and then random set is set to be 10. We fit the model, and then we return the model. We evaluate the model using the function evaluate, which accepts the model that has been built, the train data, and then the target data. And then we save the model using the save model, which accepts the model as well as the file name. There's a simple function called the explain variance, which is used to evaluate the model in terms of explaining the variance that has been covered by the models. Then we have the report accuracy, which returns the accuracy score. These two utility functions is used to automate the process of merging a particular branch if we are going into production. And then we have a small function which helps us to write metrics. In case there is a question while I'm presenting, I will not be able to see it. So if someone can kindly read it out for me, or pause me if there's an issue somewhere so I can point it out. Okay. And then we have the write metrics, which is used to write a file out explaining the training variance explained and then the training accuracy. And then this function is used in the main function, what we call the load data function that we have defined up here. This is the data here. This is what the data looks like. Then we call the transform method, which helps us to transform the data, and then we build the model with the build model class, build model function. We evaluate it, and then we save the model into a folder called model, and then it's called, the model name is called load predictor model.pkl, which you can find in this folder. And then we have the train score, which we use to explain the train score, which store the explain variance as well as the accuracy. And this is where we are plotting the future importance of the model so that we see which features that we have selected are important in the model.
Hello?
Yeah?
Abubakar, can you hear me?
Yes, I can hear you.
I love what you've just done now. It's beautiful what you just done using this code. But at times, it's better when you are building the model, when you want to build the model before you do the app deployment, is to do it in a Jupyter notebook. I understand this code is a good editor, but Jupyter notebook would have been this. Then you can use the app way in doing the model, so it look more presentable. Sorry to say, I don't know if I'm wrong, sir. That's my opinion. Thank you.
Okay. Thank you. Duly noted. I just I feel that this, but if you want the Jupyter notebook, we can like go and use the Jupyter notebook. It's not an issue. You know? The The only thing there is, actually, let me see if we can start the Jupyter here. All right, so just to create the steps for everybody to follow along, we importing the required. Am I still audible? Hello?
You were.
Yeah, you are audible.
Okay, thank you. So we are using this pandas library for data transformation. We are building a classifier, so I chose the random forest classifier. We are evaluating it using the accuracy score, and then we have some plotting libraries, the Seaborn, the Matplotlib, and then we have the Pickle, which will help us serialize our model when we are done. Okay, I'm just going to run that. Okay. Alright, and then we have a small function which helps us loading our data. Basically, what it's using is using the pandas library to it's using the pandas library from the it's using the read CSV function from the pandas library, and then it takes in the file paths to help us loading our data. Create a little bit of more function.
Excuse me.
Yes.
Excuse me, I have a question regarding the library Pickle. I am not familiar with this library. What this library do?
Which of the libraries?
Pickle, the library, the
Pickle.
last library is written after the matplotlib.
Yeah. Okay. So Echo is a library that is used to serialize our model. In other words, it is used to um, convert our models into a binary format that would enable us save it in a file that we can see, and then we can like load it into another instance, or it will give us like a TXT kind of file, but it's written in binary format. So it serializes the model. Like when we build a particular model, say model is equals to random forest classifier, and then it's kind of difficult for us to like make use of the model outside of the Jupyter notebook. For us to use the model outside Jupyter notebook, we need to serialize the model, and then Pico allow us to do that. Do you understand now?
Yes, thank you.
Yeah, no problem. Okay, so I'm going to go locate the data now. I think the data is now here. Okay. So going to like move it to alright. Then we should see it here. Okay. So what the data that I'm loading is here. Is in the same directory um, as the Jupyter notebook that I'm running. Jupyter notebook that I'm currently running is here. Okay. So I'm just going to read that in. Right. So on data.csv. And then we're just going to check if that's successfully loaded in here. So we can see the data has been successfully loaded. And then we have some of the features. We can decide to do a little bit of EDA and then try to check the information. So we have the column names, we have the non-null values, these values that are present that are not missing. And then we have the data type. We have the loan ID is object, gender is object. We have some floats, data points here, and then we can check the number.
Sorry, another question regarding the data. The data
Yes.
you are using, it's not the data of Canada government. It's not regarding the data that we have to work in. It's different data, right?
No, it's the same data. The data I'm currently using is the same data.
But this is not about COVID, Corona COVID, see?
No, I'm not talking about Corona COVID. I am talking about loan prediction. That's the data I'm using.
Okay. It's different data. Okay, just for practicing, and we can. Okay, thank you.
No problem. Okay, so just to check the total missing values that we have. So, and then we can see gender has about 13 missing values, married column has about 3, dependent has about 15, and the rest of this. Okay, so I already selected the features that I was going to use, and then we're just going to go with that, because after building the model, I noticed that these models will actually have a higher accuracy when they were selected, and that's why we're going to be using them. We have a function called transform data, but for the sake of simplicity, I'm going to be writing out the code, so you see, and then I can explain what it is doing. Gender is equals to of gender. That is me selecting the column name. And then I'm using the mark function, which will help me to mark all values where male is seen to 0, and then all values where female is seen to 1. So if you notice, the kind of data that we currently have is gender. So we have male, female, and Alex. Maybe we should do sample gets data types. Okay, so there seems to be the data seems to be male dominant. So it has male, female. But when I run this cell, I should be able to. It will mark all instance of male to 0, and then all instance of female to 1. We can easily cross-check this by saying I run the same code here. And then that has been marked. So the null values says this is missing and is not present there. So that has been marked. We are going to do the same for married, and then we are going to do the same for loan status as well. So I'm just going to copy the code from here. Thank you. Okay. So the same thing that applied to gender here is what we are applying here as well. So we are converting the married column where no, we change it to 0, and where it is yes, we change it to 1. And then the same thing goes for loan status, where it is n, we change to 0, and then where it is y, we change to 1. And then from here, you would agree that loan status is y and n, so that's why we are converting it here. And that is all of that is the simple data transformation. And then I'll be dropping the missing values as well, because they are not much, and then we can just decide to drop them. I'm deciding to drop them now. So let's do df is supposed to give those drop any. So drop any is a function in pandas that allows us to drop missing values in our data frame. So that has been successfully executed. And then I'm selecting my features as well as my target. Right? Okay, so I'm selecting the gender, married, applicant income, the loan amount, and the credit history as my features, and then I'm selecting the loan status as my target, which is like I have the feature labels, and then I have the target as well. Okay. And then with this, we can do x ahead. Then this is all our features, and then we can do y ahead. Then it shows us our target as well, and that is all about the data transform. And then since we have our features ready, according to the steps in building models, the next stage is to go to building the models. We have already imported the random forest classifier, which we are going to be using to build the models. So all we do is instantiate the class. We can call it anything. So I'm just going to with model, and then I'm going with random forest classifier. And then I can decide to add some hyperparameter tune to it. Then I'll just say we have three is the default, I guess. Then we have a random state to be any value because it's random. And then so this is us initializing the model. And then we need to do model.fit. And model.fit says we can build the model. But before we do that, we can decide to test our model just before we build it, so we can split the data using this train test split. In our case, we have a very small amount of data. If you look at the x.shape, you notice we only have about 480 data points. So we can still decide to use train test split to split the data, but in my case, we just go straight to building the models. Okay. And then when I run this cell, the model has been built, and then it is ready. Go to model, we get something this. So we get something like this. So the model is ready, and then we can decide to evaluate the model based on the training data, and then see how well it has learned from the model. So we're going to be using the accuracy score to predict the accuracy of the model. So we can say accuracy score, and then we would use the model not to predict x, and then we have the y. Okay. So model has already been built, and then it has the predict method. The predict method takes in the data point that we want to predict on. In our case, we are predicting on the training data that we have built into production. We would have to split the data and then evaluate it on a separate data set. We are going to train with the train set, and then we're going to evaluate on the test set. Okay. But for demonstration purposes and learning, we're just going straight with this. And then it says that it has about 81% accuracy score. And so this has been the model says, the accuracy score says the model is 81% accurate. So since if we are happy with this, we can go ahead. We can decide to do hyperparameter tuning, probably change max depth to something else, or probably looking for more data to improve this accuracy score. But in our case, we are going to accept this and move on to saving the models. So for us to save the model, we're going to use the Pico library that was discussed here. I'm going to use the Pico library that was discussed here. For us to do that, we would say open. We're using the open library, open method to create a file that does not already, that is not existing. If you check the working directory, there's nothing like model here. So if we go back to code, and then we say saved model is equals to open, and then we say loan predictor .pkl. This is the extension for Pico files, and then we need to state the mode at which we want to open the file. So we are using the write binary mode to save the file. Okay, and then this is so saved model now contains the file location for this, and then we can do Pico library that was imported above, then done. So people that dunk will dunk the model that has been created into the file that we have just created. So this is the model that will be dumped into this file that we are creating now. Okay, so we need to specify the saved model, which is like the file name, and then we need to specify the model that we want to save. Okay, and then when we do that, we run it. Wait for it. What does it say? Okay, I'm misplacing. Sorry. Okay, so the model has been saved. It is called onPredicted.pkl. When we come back here, we see the saved model. Now, when we open this, we see it's a binary, and then Jupyter Notebook can, Markdown cannot by default open this, and that's why we can't see the content of inside of it because it's written in binary. So the file has been saved. There's no need for us to report the accuracy. There's no need because we're already getting the accuracy here. So the model has been saved, and that's everything we have for this place, apart from the fact that we are using the explain variance to explain the level of variance that our model covered in our data point. That is the explaining ratio that our model has over the data that we have provided into it. And then we are plotting the feature importance. Here we can decide to plot the feature importance and just code for it. And then I think we need to save it. So all right. So the model that I will save is called model. And then we have the labels to be x.columns, and we are creating a new data frame. We are calling it feature data frame, and then we are using the pandas library to create the data frame, the labels that has been specified here, and the feature importance that we are getting from our model, and then the columns will be the features, and then their importance value. We are sorting it by importance in a descending order. These are formatting, image formatting variables, the x-ticks value, the axis, and then we're using the seaborn to set the style of our plot, and then we're using a plt.figure to specify the fixed size of our plot. In our case, we're using the 15 by 10. And then we are plotting it with the seaborn bar plot. We're specifying the x to be importance, the y to be features, and the data to be featured df. The feature df is the one we created here. And then we're setting the x label to be importance, y label to be features, x ticks to be this value that has been defined here, and the y ticks to be the value that has been defined here as well. And we're setting the title, and then the title layout, which is not like compulsory, and then we are saving the figure as a feature import as a PNG. Then we are closing the matplotlib. So when we run this, we should get the image. The image has been saved. When we go back here, we'll see the feature importance of PNG. It says that has been saved. So when we look at it, we see the feature importance. So it's a random forest classifier feature importance. The credit history seems to be the most important features in our data, then followed by the applicant income, then the loan amount, married, and then gender. Okay. So in terms of predicting which loan would be approved and which would not be approved, I think credit history has an important role to play there. So if probably someone is owing already, then the loan might just be disapproved. Okay. And that is all about the model building. Now we move on to the deployment part of the session. I'm just going to go back to see if we have any questions.
Hi, I have a question there.
Yes, please.
So in the first line, the feature importance equal to
yes.
model dot feature importance underscore. Why there is underscore? What is the difference? Can you explain me?
Okay, so our model that we have built is a random forest classifier. It has a method called feature importance underscore. The reason why we have this underscore is because feature importance is like a keyword that is present in Python, and then the feature importance underscore is specifically for the random forest that has been defined, and then that's why we have the underscore. So the feature importance underscore is actually the method name, and not just, I mean, the underscore is not just there for formality. So it's the method name that is present in random forest. Do you understand?
Okay, yeah, all right, thank you.
Okay. Right. Any other questions before we move on to model deployment?
I will say, well done, Abubakar. You've done a good work. That's good. We can now move to the next stage.
Okay. Okay. So to build the models that we will deploy, we need, as I've said in the slide, we need a minimum of the app.py file and then a requirement.txt. So we can generate a py file, a script file from Jupyter Notebook, but I've already written the code in the VS Code. So I'm just going to use that. I'm going to explain line by line. If any question, of course, please let me know. Okay. All right. So in our build model, the model that we have built is here. It's called long-predictor model.pkl. It's in the folder called model. So the start of the app.py file. You can decide to call it anything. App.py is not compulsory. Okay. We are importing the pickle module that I have explained earlier, because we use the pickle module to serialize the model that we built here. We use the pickle model to, okay, so we use the pickle model to serialize the model. We're going to need the pickle model to unserialize the model as well. So that's why we're importing the pickle model here. And then we are using, we're importing Streamlit, of course, to build the front end and the front end of our application, and then we are going to be using the Streamlit sharing to deploy it later on. Okay, that's like important part. Then we have the st.set page config. I have imported Streamlit as st. So st.set page config is like the default settings that the page would have for our application. We are calling the page title to be Streamlit model deployment. We are giving it an icon, and then we are setting the layout to be wide. Okay. We have a function called dev load model. Load model is the function. It will take in the model part, and it has to be a string. So we created a variable called pickled model, and then we open the parts. This time we are not writing, we are reading, and that's why we have the RB to say we are reading binary when we accept the part. And then we have a classifier which is equals to pickle.load. In the earlier version of the Jupyter Notebook, we used pickle.done to serialize the model. Now we are going to use pickle.load to unserialize the model, to unpickle the model. And then we are returning the classifier, and this function is called. We have a function called prediction, which accepts the features that we have used to train our model. You remember we trained the model with some features like gender, married, applicant income, loan amount, and credit history. And then we are calling the load model function that we have defined here inside this function, and then we are passing in the model part into it. Because our users needs to input categorical variables, so we need to transform it back to our integer values, because that's what we use to train. That's what we have used to train the model, and that's what we need to pass to it when we are using the model. And then we say, if you remember, we changed male to 0, and that's what we are doing here. And then if it is not male, it has to be female, because we add code that into the front end part of the code. So we are sending it to one, then we are doing the same thing for married, and then we are doing the same thing for credit history. Okay, this is similar to the map function that we used earlier. Okay, right, and then we have the prediction. So it says the classifier.predict, just as we have for our model.predict earlier on. We're saying classifier.predict, we're passing in a list. We are passing in the list of gender, married, applicants, all of the variables that was defined here. We're passing them into this place because we need to pass in all of the test data or the data point such that we'll be able to then predict with it. If one of them is missing, then the classifier will complain that the variable, the value that have been passed is less than what has been used for training. Okay, so while we are transforming the data, we also transform the label column, the target, to be 0 and 1. And then what we mean by 0 is that the loan was rejected, the loan application was rejected, and then when it is 1, then the loan application, so our model will only predict 0 or 1. So if it is 0, then we are changing it to rejected, because that is what our user will be able to say, yes, the loan was rejected. And then when it is 1, then it is approved. We'll call this prediction function. We are returning the pred, which is this one.
Sorry for interruptions.
Yes?
Just to follow you, because I missed the beginning of the presentation, so I miss to make deployment. I have first, for example, to write the code of the model in Google Colab, for example, in Jupyter Colab. Then I have to save it. Then I have to send it to Visual Studio Code to deployment and write another code to make the deployment, or the same code will be, because I missed this.
Okay, so the first session that we had was building the model in the Jupyter notebook. You just have to pass in the 5 parts of the model that you pickled in the Jupyter notebook here. Once you do that,
in this Visual Studio Code.
Yes.
Okay.
Yeah. You would need to create a file, a script, so to say, because that's what Streamlit will run to be able to deploy the model, and that's what we are doing currently. Okay, so once you pass in the file name and the location of the model that you pickled from the Jupyter notebook, you can easily run through the rest of the code, and then you will get it.
All of them will be in the same file, in the same folder.
Yes, they have to be in the same folder for easy access. Yes.
Okay, thank you.
Okay, so it returns the pred when the prediction is called. Okay, and then we have the main function. The main function will utilize all of the pipelines, so to say, that has been defined above. So the main function uses a simple HTML code, because Streamlit allows us to write HTML. So we have a div, and then we are styling it with the background color to be this value, and then padding to be this value. And then we have the header, the second header, H2, the style. We are setting the color to be this value, and then the text align is center, and then we are giving it the value bank load prediction inside the div. If you're familiar with with HTML codes, this is just us creating a simple div to store or to put in our app name, so to say. Okay, for us to embed HTML codes into our Streamlit app, we would use the markdown method in Streamlit, and then we'll pass in our HTML code here, and then we'll say on save allow HTML to be true, and then that will allow us render the HTML code into our app that we're going to be building. Okay. I added a little bit of formatting to the code. Where is it? Yeah, okay. We have the left column and the right column. I'm using the beta columns to arrange them. The beta columns, I think we should be able to see this. Let me run the code so that we would see it, and then I'm going to kill it later on, so I'll be able to explain what the code that I've written here. Okay, let's see each one. I just want to explain the formatting that has occurred here. Okay. Yeah, okay. This is the entire application, so I'm going to be explaining line by line. The bank loan prediction that you see here, that is in color yellow, that is what we have here. The HTML is the one that is responsible for that, and then you can see the name here. That's the HTML formatting. Now, what I need to explain is the left column and the right column. So this is the left column. This particular part is the left column, and then this particular part is the right column. Okay. So I'm using the beta columns method in Streamlit to create this. I'm setting gender to be in the left column, and then we check it. You see gender in the left column. I'm using married to be in the right column, so gender comes, married follows in the right column, applicant income in the left column, then loan amount in the right column, and the credit history, it will take all of the available space on the screen. And then that's what you can see. The line for credit history is a little bit long. Okay, I just want to like unify everything, and that's why we have this. Okay, now the values that are inside them, I'm using the select box. The select box will take in the header name as well as the value that it will allow you to select. Okay, so it's to take in the label name, and then this is a tuple. Instead of a tuple, you can use a list as well. So I'm using a tuple, the male and the female. So that's what we can see here. So it's a select box, so we can easily select which one we want. Select male or select female, then it will change automatically. Yeah. And then the same thing applies to the married, and then the applicant income loan amount. I'm using the select box to allow us to do this. This is because if users want to use this, it should be easy for them to use, and then just clicking and clicking will make it a little bit easy. And then that's one of the reasons why I've shorted the features name, because we have a lot of features in this data. So if we use all of the features, then it might be cumbersome for the user of the app to use it, because they have to fill in a lot of variables, and then they might not be able to do that. Yeah. Okay, and then we have the empty results. We're going to use it later on. Okay, so when predict is clicked, this is what happens. We say if st.button predict, that we created a button called predict here. That would create a button called predict. So if it is clicked, that is what this line is doing. It's saying result that we define here to be prediction, which is the function that we define here. Yeah. Prediction to be taking all of these values. All of these values will be passed from this place, so it's easy. So all of these values. So and then it will return either rejected or approved. Yes. So. So if result, this one here is equals to rejected, we just want to use st.error to say loan is rejected, and then we say sorry, and then else we want to say success, and then loan is accepted, and then we say congratulations, and then we want to throw some balloons up in the air. Okay, and that's everything we have done for the front end of our application. And then don't forget, we are loading in the model that we built from this place. In my case, I have it in the model folder and then the loan predictor. The reason why I could use this is because the app is outside the model folder, so I can easily just go into the model folder and then locate a file called loanpredictor.model. Okay, and then when we do this, we have if name equals name, we want to run this, and then for us to run the app, close this. So I've stopped it. For us to run the app, we use Streamlit run app.py. Okay, the file name is called app.py, and then because we want to run a Streamlit, we can decide to run a Python file to like check if there is any syntax error or the rest. But we already know what we want, so we're just going to do Streamlit run app.py. Then hit enter. It should start. Okay, so you can have your Streamlit app in your browser. Then we can decide to click on this and go there, or click on this and go there. Okay, in my case, I have it already open. Just going to refresh it. Okay, so this is our app. We have the bank loan prediction. So we can select the male that we want or female. So let's assume a female wants to use this. Let's say married. You can't monthly income. So we can specify monthly income to be probably say about $2,000, and then the total loan amount to be about 80,000. And then do we have unclear debt? If we have, we say yes we do, or no we do not. Okay, so in our case we say no, unclear debt, and then we're going to like predict, and then it is running, as you can see, and then it says loan is approved, congratulations. Yeah, and then you can see the balance go up. All right, and then we can test for the case of denied loan. So to say, let's assume we are earning about let's say 1,000. 1,000, and then you want 19. Okay, and then you probably have some unclear debt which you need to buy car. Okay, all right, yeah, good. And then it says loan is rejected. Sorry. Okay, this is just what we have coded here, and that is what we are seeing here as well. Okay, any questions so far before we move on to, because we have built the front end, now we need to move on to the deployment part. Any questions? No questions? Okay.
Everything is in order. Move to deployment.
What? What did you say? Okay.
I said there's no question by me. I can move to the deployment stage.
Okay, thank you. So for us to deploy our app using, for us to deploy our app using Streamlit sharing, this is already running on our local device. So we can come here and then we click on deploy this app. Okay. So before we can deploy an app, we need to give Streamlit access to our GitHub, just as I've specified in the slide earlier. We need to give Streamlit access to our GitHub account so that it can be installed as an authorized app. And then we need to have a repository, and that repository must contain an app.py and then the requirement.txt. If you look at the file structure here, I have the requirements.txt here, and then I have my app.py. Okay, and then my app.py is making use of this model, so I need to add that as well. And then I've built a simple Docker container for it as well. I'm not sure time allows to talk about that. So for us to deploy when the app is running, we click on this place.
The other TXT, what does that one contain? Which file? Is it a requirement?
No, it is called metrics. It is metrics, okay. And then it is.
And what does it contain?
It is used to store the explained variance ratio as well as the accuracy score. Okay, I intend on explaining the continuous machine learning part where we make use of the metrics.txt file. So that is what it contains. So it's different from the requirement.txt file. Okay.
Okay. Does Streamlit need it to, in order for you to grant GitHub access to it?
No. What Streamlit needs is the requirements.txt file as well as your app.py file, just as I've specified.
Okay.
Here.
Okay.
So all it needs is these two. Once you get this, it will work.
Okay. Yeah. Okay. You can continue. Sorry, you can continue.
Yeah. Thank you. So we click on this place and then we click on deploy this app. When we do this, your repository has uncommitted changes. Please commit the latest changes and then push to GitHub. Okay. So I'll need to go back to my code. I'm going to unstop this and then create a new one. Let's see. Okay. So if I do git status, says there's some file that I need to update. It needs the data because I moved it earlier on from the data folder, but I'm just going to commit it and see what comes out of it. So just do git add. So I'm just going to call it presentation because that's what we're doing. I'm just going to say push. There we go. Okay. The reason why Streamlit code integrates easily with my GitHub is because this app has already been deployed and then it already has access to it. But for the if it's like the first time they're using it, you will see once you see this place, you click on deploy this app. It will ask you to continue with GitHub or you continue with Google. I would advise you use the continue with GitHub because then it is easy for you to like install Streamlit on the GitHub. So once you click on continue with GitHub, it will automatically install Streamlit as one of the trusted apps on your GitHub repository, and then you can Streamlit has access to the repository, and then it's easy for you to deploy. So if that happens, you will get a page that looks like this, and then it will say your name and then the repository name. It will automatically detect this because it has already been created. Your name and the repository name, and then you want to specify the branch at which you are committing it to. In my case, I am using the main branch. Okay. So I'm going to select the main branch and then the main file path. In my case, it is called app.py. If you rename the file name, you can call it main.py or anything.py. So if all of this is checked and correct, and then you have the requirement.txt file, all you have to do is click on deploy, and then it will cook the file for you, create an environment folder, and then the app is deployed and everybody has access to it. And then once the app is deployed, you see a bunch of, let me enlarge this so everybody sees it. You see this part pointing to the steps that have been taken. It will install all of the libraries that has been specified in the requirement.txt file so that the app will work. And then you get an interface that looks like this. And let's go back here. Deploy this app. Okay, so similar to what we had before, and then I can easily click on deploy. So if this is not a repository that has been selected, you can select other repository that you have in your GitHub. Okay. In my case, this is this, and then we have the main branch, and it automatically locates this. But if it is wrong, you can change it and then select that. But in my case, I already have one branch, so main, and then the py file. There's no need for the advanced settings because you're only setting the Python version and then the name, which in our case we're not actually doing much for that. And then we just click on deploy. Then we're going to wait for it, and then it says success. So it runs the app. So we wait for it to connect. Take a little bit of time because I've already done this before, so it's much faster. So if you're doing it to install all of the dependency, you can see it's a little bit long. So it will install all of the dependencies, and then once you test it, so you have like online version of it and not your local. I mean, it's not running on the local host anymore. So you have the we can say mail 5,000, and then we want just 100,000, and then we don't have any yet. And then it says loan is approved, congratulations. Then it shows on this. We can remove this just in case we don't need it, and then we have all our app. So the app is ready, and then it's in here. Okay, that is how we deploy our Streamlit model using the Streamlit share. Any questions? I guess no. Okay. If time permits us, I created a simple Docker image for the app so that we can easily run it on Docker. So I'm just using calling the defined Python version. We are creating a work directory. In the second line, we are specifying we're copying the requirement.txt here to the working directory here, and then we are installing everything that is present in the requirement because we have to create the environment as well. We're exposing the port 8501. If you noticed, the app is running on 8501. Okay, and that's why we're exposing it here. and then we're copying from our current directory to the working directory, the app that has been, this app file has been created. We set the entry points to be Streamlit run, because of course that is how we run our app. Say Streamlit run, and then when that happens, we want to run this command app.py, and then we can easily build our image with the Docker build. I've already built the image, and then it takes a lot of time to complete that. So we can use something like Docker build ft, and then we can specify the app name. We can say loan prediction, and then we can add a tag to say latest, and then we can say space this, and then this should build our app first, and then when that happens, when you run it, it will take a lot of time to build the app. So I'm not trying to repeat that, and then we can do Docker image, the check if the image has been added. This will list out all of the images that we have in our folder, and then you should see the load prediction or whatever the name you have specified. And then for us to run it, we just do sudo run. We do sudo docker run, then specify the port. In our case, we're exposing the 8501 into 8501 and the app name. So you can say load prediction. You can add the tag as well. And then when you do this, it builds the image, and then you can easily access it and run it through on your local device. Okay. And yes, so that is all about my presentation. Thank you very much for coming. I hope I have been able to at least teach you something today. And then if you have any questions, you can ask right away. Thank you very much.
Thank you for the session, Abu.
Yeah, you're welcome. So the GitHub link to the code is this. Let me show you. It's already in the slide that I shared earlier. Oh, that's the GitHub link. Any questions? Okay. I think there's no questions. All right. Thank you very much for coming.
Thank you so much.
Yeah, you're welcome. Cheers, everyone.